Hello, I'm Leonie Mimner, an application specialist at Foster+Freeman. I specialise in the VSC range and question document examination. Today I'll be giving you a glimpse of the new flagship VSC, the VSC 9000. I'm going to highlight the latest innovations and developments in the world of question document examination. In this webinar we will cover the new and improved features and their various applications. One of the most significant changes to the VSC 9000 is the completely redesigned optics, producing the highest quality images in VSC history. Sharpness across the whole image has been improved and significantly less chromatic aberration is being observed by the camera. The VSC 9000 now utilises a dual camera system. We have the main 12 megapixel camera for your general examination using all the light sources and the high magnification possibilities. But we also have a secondary A4 camera. The A4 camera is also 12 megapixels and it allows you to view a full A4 document. This could be anything such as a breeder document, marriage certificates, birth certificates, naturalisation certificates, but also contracts, wills, doctor's notes and more. The A4 camera can be used with multiple different light sources. So we have our white floodlight for your overall examination. We can also use infrared to look at reflectance and absorption of inks and printing. We've got UV 365 to look at any fluorescent features such as fibres or fluorescent inks. We've got transmitted lighting for any embedded features like watermarks or maybe even evidence of tampering. We've got the OVD viewer for looking at anything holographic, so this could be maybe a holographic seal on a certificate. We've got side lights for looking at any indented or raised features on our document. And finally, we've got the bandpass filter for looking at visible and infrared narrowband illumination. In the new VSC 9000, we can now achieve a 480 times on-screen magnification. What I can do is drag the slider bar here, and using a close-up lens, we can start to look at the printing here. We are now at 480 times on-screen magnification. This is where we can start to look at the actual fibres of the paper and look at the fine details of the document. We're now at 209 times on-screen magnification and we're able to see some microdots which have been planted into a paper document. We've got a few new additions to the light sources in the VSC 9000, one of them being the 495 long pass filter. This gives us another level of inspection when we're doing infrared examinations. But what I've got on screen here is the new wavelength of UV, which is our 385. So this is a longer wavelength of ultraviolet light. Now we've got this wavelength for many reasons. You can look at it, look at UV security features, so fluorescence like we've got here, but also it is more sensitive for looking at UV reflectance and absorption. So this is where we can employ a UV bandpass filter so that the camera is viewing in the UV. We're not viewing the fluorescence which is in the visible part of the spectrum. In this case, what we've got here is a document which has had a chemical solvent applied to it. And when we look in the UV part of the spectrum, we can actually see the outline of this. If I go back to the visible, where we've got the fluorescence, the outline was not as clear. The 385 is much more sensitive for this application, where we use the bandpass filter instead of a visible pass filter.
The 9000 also has extended access control, so this is something that we've been working on. The EAC, as we know it, provides extended access control to passports. So all of the data groups that you have that might be images of fingerprints or whatever countries want to put into these data groups, we've provided the user with access to this. And in quite a low level detail, and you can also generate reports gaining access to all the checksums, direct image comparisons, or be able to bring in various country certificates. So this is all, for those that understand and know these features, this is quite a big improvement on previous VSCs.
Machine readable zone decoding is now easier than ever before. Simply place the document inside the VSC and we can activate the travel document OCR tool. AI Assist means that the user no longer has to position the document in a specific position within the VSC. The MRZ can be read quickly and easily. The VSC 9000 now has advanced chip interrogation capabilities in the form of a procedure called extended access control. What this allows the user to do is open a range of data groups hidden within the chip. Information such as signatures, biometrics and personal data can be probed. So I've placed our document on our eChip reader here, and with extended access control we are able to read more information than ever before. What this involves are things such as secondary images, like in data group 5, data group 7, which as you can see here, we've got a signature, and also other data groups like data group 13, data group 14, and data group 15. Now this will all depend on the document that you have and whether these passports or travel documents have extended access control capabilities. The HDR imaging allows us to capture multiple images at different exposure settings, and this helps to compensate where there may be areas that are slightly overexposed and areas that are slightly underexposed. If I compare that with the original, we can see that it's helped to brighten up these areas here. And particularly, if I navigate to where the thread is, we can see that it's brightened up the printing on top of that. The HDR tool also allows you to customize which exposure settings are used. So if you want to up the exposure of image 1 or lower the exposure of image 3, you can do so. The VSC 9000 now has an updated and refined 3D imaging software. We can now use different wavelengths of light when capturing our 3D image. This is especially useful when imaging maybe holographic or reflective documents. Essentially, using the infrared light can help to negate any unwanted anomalies in the image that can be caused by visible reflected light. So what I'm doing is I've selected the wavelength that I want the 3D image to be captured in. I've just gone for 780 in this case. Making sure it's in focus and processing the image. So I'm just selecting my region of interest and generating the image. So on the left-hand side here, we have a banknote captured with the 3D using visible light, and on the right-hand side, we have the same with infrared at 780. Now with the visible, what we can actually see is where the holographic strip is here, it's actually caused some interference with the 3D imaging, and this is just purely from the hologram. If we look at the infrared image, we don't have that reflection of the light, and therefore it's not present. The VSC 9000 has an improved spectral resolution of 2 nanometers. We can use the spectrometer to measure absorption, reflectance, transmittance, or fluorescence. The result of this is we have more data points for a given spectrum, more points of comparison, and more likely to be able to differentiate between 2 very similar inks. So first I've set the magnification, and now I need to take a white reference for the spectrometer. I am just using the calibrator tool, which we provide as an accessory alongside the VSC products. Once the VSC has taken a white reference, we can then start looking at the spectral measurements. What you can see here is the live spectrum at the bottom of the screen, and once you are happy with the measurement, you can copy that data to the spectrum screen. When you're using the spectrometer, you want to take as many measurements as possible, and this is where the XY stage can work incredibly well at locating parts of the document for you. A simple double click will allow you to navigate the document in small distances. This is the lamp maintenance panel in the VSC 9000. As you can see, there are only 2 bulbs that will need replacing by the end user. This is because we have evolved to LED technology. Short and mid-wave ultraviolet light sources have now transitioned to LED technology, meaning that there is minimal maintenance required by our end users. Anyone familiar with previous VSCs will be aware of the lamp tray that we used to have to pull out. No longer the case for the 9000 because it is.
The VSC 9000 also has an improved coax lighting module. So it's actually something that was developed as part of the Chronout Auto. We realized that actually if you go to a slightly imperfect coax lighting array, so slightly off axis, you started revealing certain other bits of evidence. And so we tried it on the VSC and actually found it was useful on some kinds of laminates where you could perhaps see some signs of alterations or imperfections, just kind of helped reveal a few things. So we've implemented that in the VSC 9000 and got also been able to give some size control as well. So you can modify the light source to try to either look at a retroreflective feature or perhaps move to a smaller source to try to look for scratch or score marks or various other alterations.
In the VSC 9000, we have made big changes to our coaxial light source. Firstly, the field of view has been significantly increased, allowing us to reveal surface features across a larger area. On this driving license, we can clearly see the laminate embossing and engraving here due to the coaxial light source. We've also added an entirely new feature where the user now has the ability to configure the light source. The active illumination can be selected to be in a off-axis mode, which means that you can select either the left, middle or the right side. So at the moment we have the full illumination here and we can see the embossing and the engraving in the surface laminate. But when I use the left side of the coax box, what we're now doing is using that off-axis illumination, and we can see the 3D properties of the laser engraving here. So this allows us to look more at the printing processes and the laminate features which can be used to interrogate and authenticate our documents. The Edge Viewer is the newest addition to the VSC accessory range. It allows the examiner to inspect the edges of the document, specifically for a security feature called an edge seal, which we have present on this driving license here. The laser printing on the edge requires a high magnification and an angled view to be captured successfully. The new edge mirror allows us to do this quickly and easily. The Edge Viewer can also be used to look at the laminate composition, As you can see here, the fraudulent document has a very different layer structure.